your warm-up is going back to what we talked about yesterday with parabolas. I just want to talk about which way are these parabolas opening. Okay, so yes, the first one is right. How do you know that it's right? The y is being squared, and it's positive. Good. What about the second one? Down. How do you know it's down? The x is being squared, and it's negative. Very good. Any questions on the warm-up for today? All right, today we're doing 10.3. It's our next conic section. It's all about circles. I told you guys parabolas were my favorite conic. I think I might have actually lied. Circles are, I think, the easiest conic, so therefore they're sort of my favorite as well. There's a special place in my heart for all the conics, but I think you will find circles to be the most enjoyable. No, you don't really need graph paper. You're going to graph, but you can just sketch them. These are not very, very complex. You'll see when we get into them. All right, so first of all, let's just talk about what a circle is. I would probably make sure you at least get this. But below that, you will find the definition of a circle. It says a circle is the set of all points that are equidistant from a fixed point called the center. The distance r between the center and any point, any xy coordinate on the circle, is the radius. So down here is how you would construct a circle if you wanted to draw a perfect circle and you only had a few tools. Right here, there's a nail. That's the center of the circle. And then some string. The length of the string would be the radius. You attach a pencil to it, and you go around. That's how you would make a circle. So every point that ends up being on this circle is r distance from the center. So the main thing today is to find r. When you're given an equation with x squared plus y squared equals r squared. So you'll have to take the square root of the r. That's your radius. Have to locate your center. And then you can just start filling in some points that are that many units from the center and graph that way. What are your questions about circles? All right, here is an example. You don't really need to write this one down. You can just sort of relax, soak it all in, and then we'll get into the real examples. So we are now looking at an equation in standard form for a circle. So this is the equation I gave you on the last slide. Pay close attention to this value. Whatever is being squared is our radius. And we're looking at ones with the center as the origin. So there's my center. Now, let's say that instead of giving you r squared up here, I told you, well, that's going to equal 16. What would the r be if the r squared equals 16? 4. So the radius of this circle is 4. That means we're going to think of all the points that are 4 units from the center. So there's one, there's one, there's one, and there's one. And there's lots in between. Those are just the easiest 4. So once you find, usually we do 4, just one in each direction. Circle them with a circle, obviously. Some students just kind of connect the dots. That doesn't work. This is not a diamond shape or a rhombus. It is just a circle. So make it a smooth curve all the way around, going through each of those points. Any questions on our first circle? All right, here's where I want you to start graphing along with us. Now, I said these are pretty basic graphs. If these were my notes, I would just sketch them right in the notes. It won't take you long. They're not too complex. Can anyone tell me right away what the radius is going to be? Yeah, 2. Because it's the square root of 4. Which is 2. Again, my center here is at 0, 0. You can see there's no transformations going on. X and Y are just both being squared. So center is at 0, 0. So I'm going to go R units in each direction. In this case, R is 2. And then I'm going to connect them all with a circle. A smooth, curved circle. What are your questions? I told you circles. Do you feel like circles are your new favorite?
Yes.
Yes. All right, here's number 2. Oh, you're taking away all the fun. R equals 10. Center says 0, 0. So you're going to go 10 in each direction. Fill it in. See? Conics are the best. What?
How many examples are there?
10.
Of just this?
No.
Oh.
We're going to start looking at the equations. Basically, I mean, it doesn't, there are some where we have to find the radius, so we're going to use some distance formula stuff. But yeah, this is basically the gist of circles. Questions?
R equals 6.
R equals 6. Again, no transformations going on with our x or our y, so our center is at 0, 0. 6 in each direction. You can see on my graph I'm counting by 2s just to save some paper. I think on the last one I was counting by 5s to save some paper. So depending on, or sorry, counting by 2s, so I had 5 units, sorry. But yeah, pretty simple. 6 in each direction. Draw your circle. Questions? Now, sometimes you actually have to get a calculator out. So we need to do the square root of 12, which, yes, would be 2 square root 3, but do you really know where that would be located on the graph? Not really. So decimals are going to be a little more beneficial. It's somewhere around 3.5, so now I'm just going to go 3.5 units in each direction. So even if it's not a perfect square, on the right side of your equation, you can still graph these pretty quickly. Just type it in. Questions? All right, here's where it gets a little trickier. This says, write the standard form of the equation of the circle that passes through the given point and whose center is the origin. So I basically need to find the radius. The radius is the distance from any point on the circle to the center. Where's our center? 0, 0. So I need to use the distance formula to find the distance between the point 2, negative 1 and the point 0, 0. So here's the good old distance formula. I'm going to subtract the x's and subtract the y's. It appears that we are calling this x2 and y2, and then the 0, 0, the x1 and the y1. So using the distance formula, I would have 4 and 1. So my radius is square root 5. Any questions so far? So what would the equation of this circle be? What do I start with a circle? X squared plus y squared equals, do not forget to square the radius. The radius is the square root of 5, so you have to square it. Well, what's square root of 5 squared? 5. So our equation for this circle is x squared plus y squared equals 5. What are your questions on this one? All right, here's another one of the same type. So they are telling us that our circle goes through the point 1, negative 9, and it has a center at 0, 0. The whole problem with circles is finding the radius. Once you find the radius and the center, It's super easy. They already gave us the center. It's the origin. I need to find the radius. The radius is the distance between the center and any point on that circle. So I'm going to use the distance formula, the point 0, 0, and the point 1, -9 to find my distance. So I need to subtract the x's, square them, plus subtracting the y's, square them, and then take the square root. So that's going to give me 1 for my x's, 81 for my y's, which gives me square root 82. Now you're just going to plug it into that standard form equation. So x squared plus y squared equals square root of 82 squared. What happens with the squared and the square root? Yeah, so we just get x squared plus y squared equals 82.
Will it always turn out like that?
Sometimes it will be a whole number. Like we looked at somewhere the radius was 2, so you had a 4. So no, it won't always have a square root and a squared, because sometimes your distance will work out to be a perfect square. All right, here's another one. Same setup. The circle is going through this point, 2, 3. Center is at 0, 0. In order to find my radius, I need to find the distance between that center and this point. So I'm going to use the distance formula. So I'm going to subtract my y's using that other point as my center, 0, 0. So it's going to give me 4 and 9. So I'll have the square root of 13. So you're going to plug in the square root of 13 for the r in our equation for a circle. Simplify the right side, square root and the squared go away. You just have 13. So x squared plus y squared equals 13. Questions on this type? Would you like to see another? Okay, let's speed through this one then. Here's another one, same type. We're going to use the distance formula with the center 0, 0. You end up getting square root 17. When you square it, you get x squared plus y squared equals 17. All right, let's get into the next type. So you will also see ones like this. Now this is actually even simpler because they don't give you a point. They give you the actual radius. So you don't need to use a distance formula. It's like they did that step for you. So this says write the standard form of an equation of a circle with the given radius whose center is the origin. So if they give you the radius, just plug it in. You don't even need to use the distance formula.
Radius is 1.
Now, when you square 1, what do you get? 1. So x squared plus y squared equals 1. This is called the unit circle, just so you know, when the radius is 1. Fun stuff. All right, last example of the day. So I am telling you there's a circle, the center's at 0, 0, and the radius is square root 7. What's the equation?
X squared plus y squared equals 7.
Yeah. So you need to plug square root 7 in for the radius. You always square the radius in this equation. Something with a square root squared. Those go away. You have x squared plus y squared equals 7. Any questions? All right, I did modify your homework assignment. I actually forgot originally to put any of those where you're writing equations in, so I added 3 of those on the end. These 2 you're given the radius. This one I think you're given a point and you have to use the distance formula. The rest of these are on your green sheet, but 47, 49, 59, please add those. Any questions?